This video is going to overview virtual and remote laboratories, providing an example of this digital tool. What is a virtual laboratory? It's an emerging digital technology. It helps to simulate physical laboratory experiments without the need for expensive equipment or lab space. This tool is usually housed on a website. The benefits of a virtual laboratory are that it's cost-effective, getting rid of the cost of expensive lab equipment. It's safe for students because they can learn in a safe, controlled manner before they use an actual laboratory experiment. It encourages independent learning and provides access to lab materials to students outside of their scheduled lab time. Virtual laboratories have many possible applications in education. Here are two quick examples. Chemistry labs require resources such as chemicals, lab benches, beakers, safety procedures, and adult supervision. Students can benefit from seeing the outcome of various experiments, visualizing reactions, and analyzing properties of different materials without needing to be in a physical laboratory. Physics labs experiments can often be expensive, bulky, and very time-consuming. Students can visualize properties of motion and other physics concepts without dealing with these constraints. There are different ways to use the technology both by teachers and students. Teachers and other educators can use virtual labs to assign pre-lab assignments, homework alternatives, or post-lab concept testing. These tools can also be used to help teachers design future experiments without having to conduct the experiment physically themselves. Students can use virtual labs as a pre-lab study aid, a supplemental lab data and outcome, understanding step-by-step reactions, and for individual concept testing. Basically, any way they could use more information for class, virtual labs can help by supplementing that resource. An example of a virtual lab tool is Chem Collective, which is a collection of virtual labs, scenario-based learning activities, tutorials, and concept tests. This free online tool can be used to simulate various chemistry experiments. When evaluating Chem Collective, I used this tool evaluation checklist, including criteria of cost, accessibility, ease of use, reliability, and relevancy. As you can see, Chem Collective scored a total score of 56 out of 60. Here's an example scenario of when you might use Chem Collective. Consider a college freshman taking a chemistry class for the first time since high school. They keep up well with lecture concepts, but struggle a bit in the lab course. Even though the student is organized and good at following directions, they have difficulty understanding how experiments should turn out or drawing conclusions based on their lab results. This student needs a tool that can help review similar experiments and see step by step what occurs in a reaction. Chem Collective offers a variety of lab activities to help. Imagine that student in question needs help with the concept of equilibrium. Chem Collective offers resources by topic or resources by type. You can see here on the screen that this is the Resources by Topic menu offered in Chem Collective. The student can explore this topic to see all relevant resources available, including virtual labs, concept tests, lecture tutorials, and simulations. You can choose a resource such as a virtual lab experiment. By following the virtual lab instructions, the student can then visualize physical properties of the experiment, including color change, thermal properties, equilibrium of a solution, and pH. Students can also watch lecture videos to explore concepts, test themselves with guided problems, and test their knowledge with concept tests. Next, we'll explore the tool for the scenario that we just discussed. This video is going to overview how to use Chem Collective, a virtual lab online tool. Let's say, for example, this student needs help with equilibrium. Here you can see there are other concepts broken down under equilibrium. Within each concept, you can see concept tests scenario-based activities which you can perform in the virtual lab, various tutorials which can give you different lectures, and virtual labs that help you explore safely. Let's start by looking at a virtual lab scenario for equilibrium. Here you can see the virtual lab stockroom. To load in any experiment, you just go to File, Load an Assignment. Here we can go underneath Chemical Equilibrium and load this cobalt experiment. Once you're inside a virtual lab workbench, you can see the stockroom on the left. This gives you a list of solutions, glassware, and various tools to use within your experiment. When you click on the lab name in the upper right corner, you will see the objective, background, and assignment of the lab. The objective of this lab is to gain an understanding of Le Chatelier's principle of equilibrium through observing the effect of messing with the equilibrium distribution of various cobalt complexes. Skipping through some of the actual chem content, since that's not the topic of this video, I'm just going to start performing the experiment to show you how the virtual lab works. The first step of this experiment is to add 25 milliliters of a solution to an empty Erlenmeyer flask. You navigate to glassware and choose the flask that you want, and it immediately shows up in your workbench. Navigating back to solutions, I can also choose the solution I want, which shows up on your workbench as well. In order to fill my flask with this cobalt solution, click and drag the solution onto your flask and choose what volume you want in milliliters. Now that that's done, I can continue to the next step of the lab. Going back to the stockroom, I'm going to grab hydrochloric acid and add it to this flask in 1 milliliter increments. As you can see, as I add this acid to the flask, there's a noticeable color change, and it's gotten darker from before. If I neutralize the solution with silver nitrate, adding it in 1 milliliter increments as well, I can neutralize that cobalt solution and reverse the color change, getting back to the original color of my solution.